Hi and welcome. I hope everyone is okay. If you remember, we stayed in the Poisson district. Before that, I want to give a brief summary of what we learned the last lesson about the Poisson distribution as an approximation to the binomial distribution. If you remember, we have some graph about Poisson distribution. And in Poisson distribution, your mean is equals to 1. Your graph or curve is like this. This curve is very skewed. But if you lambda is equals to 3, bigger than 4, so your curve is similarly symmetrical like this. And if you lambda a bit bigger than before, so your curve becomes very symmetrical. And if you look at the binomial distribution graphs, and the first value means n, the second value is pi, the probability value. So in the nu equals to n times pi, so 10 times 1 0 1 0.1 1. So nu and lambda, the same things. In the binomial distribution, your curve very cute, and your nu is bigger than before, like 50 times 0.06. So it's 3. Your curve becomes symmetrically before that. And if you look at the last graph and you compute the nu, is 60 multiply 0.08 and becomes 4.8, and your curve becomes very symmetrically. So in the result of, if you compare the Poisson distribution and binomial distribution graphs, and you notice that your lambda and or equals to nu uh, bigger than before, your curve comes very symmetrically and becomes very similarly. So you remember that for about the last lesson, your trial times, your the number of trial greater than 50, and multiply 5 less than 5, the Poisson distribution mean can be used as an approximation for the binomial distribution. And our as a guide, it should be the number of trials greater than 50, and your lambda less than 5. And you can use the binomial distribution about as an approximation for the binomial distribution, that Poisson distribution. To find out how good an approximation a Poisson distribution is to the binomial distribution, uh, compare exact probabilities and approximate probability. We have an example about glassware. Garrett makes glassware. An item of glassware is imperfect if it contains bubbles. Over the years, finds that the probability of any item containing bubbles 0.012. Garrett made a batch of 375 items of glassware. So, if you notice that the probability about binomial distribution, because you have probability value is 0.012, and it's the probability of success, and the probability of failure, 1 minus pi, the probability of failure, so 1 minus 0.012, and it's 0 and 8 becomes so x the x let x be the random variable number of glassware items bubbles, the binomial distribution, assuming the presence of a bubble in one item glassware dependent of the presence of bubble in another item glassware. And if you want to use Poisson distribution, you should compute lambda. Lambda equals to n multiply pi. So in this process, from this process is 4.5. If you want to use binomial distribution for solving this problem, you have much process. For example, if you want to the probability of um, 3, so you want to in the binomial distribution you should use this formula. Choose 375 tool and multiply pi to 2. So 0.01222 multiply 1 minus pi. We computed that it's 0.988 to 375 minus 2. But the binomial distribution is a process very hard. So we use Poisson distribution instead of binomial distribution. Because when the number of trials greater than and lambda less than 5, the binomial distribution to the Poisson distribution. So if you look at this table and you want to use binomial distribution, you should use this formula. But in Poisson distribution, you should use this formula. So Poisson distribution a little bit short than binomial distribution. Also, their values are very similar. If you want to the probability of 0 by using binomial distribution, this value is 0.0108, but the same value, if you want to the probability of the same value by using Poisson distribution, and you should find 0.111, and the both value are very similarly. Also, you want to probability of one by using binomial distribution, your result is 0.0492, but using Poisson distribution 0.0450. And if you notice that your value, your both value is very similarly. So the to for a very short for having very short process in Poisson distribution, we prefer Poisson distribution instead of binomial distribution. And now we will go on. We can see that the probability is correct to three significant figures. Three significant figures are almost the same for all these values, hence the Poisson is a good approximation to the binomial to use in this situation. Okay, now we have some example about the binomial distribution approximation to the Poisson distribution. A company produce electrical components. Past reports show that the proportion of faulty components is 0.4%. Means we have a faulty, the probability of faulty components is 0.04%. So it means 4 over 1000, and your the probability of success means 0.004. You want to compute the probability of failure, it should be 1 minus pi, 1 minus 0.004, so 0.996. And Harry buys a box 1,000 electrical components. Using a suitable approximation, work out the probability that A, B, C. You have 1,000 bucks, and your chance is 0.004. And exactly 10 components are faulty. If you compute the probability of 10 components are faulty by using binomial distribution, very hard has very hard process. For example, if I want to use binomial distribution, this process choose 1,000 10 bucks, multiply P to 0.004 to 10, multiply failure to 0.996 to 1000 minus 10, so 990. This process computing this process very hard. So instead of we should use the Poisson distribution. Okay, now we have our the number of trial is 1000, and the probability of faulty components is 0.004, and the first situation are real number greater than 50. Second one, lambda is used to n multiply pi, so 1000 multiply 0.004 and equals to 4 less than 5. And both the both situation shows us we can use the Poisson distribution. And if you want to compute this probability by using Poisson distribution, you should use this formula. Please remember this formula. The probability of R means lambda to R multiply e to minus lambda over R factorial. And exactly 10 components probability. The probability of exactly 10 components by using Poisson distribution lambda for 2R multiply e to minus lambda and over R factorial 10 factorial. And to computing this process, this process easier than computing this process. So we prefer the Poisson distribution instead of binomial distribution. And the second one, at most 4 components are faulty. At most 4 components are faulty means at most 4 components are faulty is the probability of x less or equal than 4, less and equals than 4 means please remember that the Poisson distribution is discrete distribution, and you should compute that the probability of 4 plus the probability of 3 plus the probability of 2 plus the probability of 1, the probability of 1 plus the probability of 0. And your formula is the probability of R means lambda to R multiply e to minus R over minus lambda over R factorial. So these multiply also on all probability. So I want to use this term the last of the process, and the first the probability of first lambda to R. So our lambda is 4. So 4 to 4 over 4 factorial plus, and 4 to 3 over 3 factorial plus, and over 2 or over 2 factorial, and 4 to 1 over 1 factorial, and 4 or lambda to 0 over 0 factorial. And then all of them has e to minus lambda multiply e to minus lambda. And we if we want to compute that, these probability we can find this section probability. And the last one, more than 5 components are faulty. More than 5 components are faulty means the probability of x greater than 5 means the probability of 6 plus the probability of 7 and go on uh, in infinity. So please remember that the Poisson distribution, discrete data, and all probability, sum of all probability are equals to 1. If you want to this process, instead of this compute, 1 minus the probability of x less and equals than 5. So 1 minus the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 and the probability of 5. And the computing for computing a very short process, I will use these multiply the last of formula, and 1 1 yeah 1 minus lambda to 0 or lambda 4 or to 0 over 0 factorial or to 1 over 1 factorial. Also please remember that lambda equals to 4, and 4 to 2 over 2 factorial, 4 to 3 over 3 factorial, 4 to 4 over 4 factorial, 4 5 over 5 factorial, multiply e2 minus lambda, and the probability of more than 5 is equals this section. Okay, now I hope the lesson is very useful for you, and for this finish, have a good lesson and have a good